test. Oh, okay. Hello, hello, hello. Okay. All right. Yes. We're here. Good time of day, be it morning or other times of day. There are other times of day. I've heard. Um, am I late? Yeah, pretty late. I mean, okay, late. I have really good excuses of why I'm late. I was not watching K-drama. No way. So we are today we are starting from the other side, which is the Carnegie Mellon University side, and not the Hugging Face side. So if I go here, we are past the first lecture. We are in the okay, second lecture. What my brain is like going through is the reading material. I haven't done any. And I know if I do, it's better for me. Even the code, I technically didn't go through it very well, and I'd rather do that than not. Like, I know the rule-based part is easy to understand. Oh, it's so well written. Yeah, so we have this list of good words and this list of bad words, and we have our script thing, and you say if any, like it's like four for each word in this list. If any of them is a good word, then give me a plus. Like, just count it, right? Good word count is something that we have. You in this features thing, a dictionary, I guess. And then we have a bad word thing. And then we have a bias. Bias is currently 1 to allow us to assign a default score to the text. I don't know if we change bias. Let me see. And then feature weights. Oh yeah, bad word is -1, so that the number we get is minus and not plus, because if I guess it just looks cooler and easier to understand. Bad is a minus and good is a plus. And for some reason this time bias is 0.5. I don't know why we did that. Did we talk about bias? So okay, data reading. Read in the data, read in the data from the training dev, or finally test. Read XY data. We have files that we read from. Okay. Can you get my LinkedIn? Hi, Abdul. Hello. So, the answer is no, because as a character, I don't have a LinkedIn, and I have no plan of sharing my personal LinkedIn. What I have is something recent, which is a Discord server that, if interested, you could join and ask questions. And I don't I don't always know answers, but I think we are creating a community that should be able to help each other, which is pretty cool. Yeah, but we are in the creating community part, not the created part. Yes, hello. Good, that's good. I'm glad. Um, it's in the description box if you're interested. Or I can just put the link in the chat. That works too. Give me a second. Copy and paste, and here you go. um, all right. So we are reading in the, like, honestly, right now, if you ask me to write this, I probably couldn't write it in my brain, but it already exists. Thank you, for the checking. But yeah, so even the output is both, right? So yeah, we're reading them. We have X and Y, and printing it just to look at what it is. I don't think I ran this. Is there a collab? Is there a way for me to put it on collab without having to download it? Okay. And where is that? Data. Oh, it's here. Okay. And then, uh, run the classifier and calculate accuracy. We have a classifier. What it does is, let me check if I remember, because the idea was we have a score for feature name, feature value, so good, and then how many good. In the feature list that we received, score is score itself, which is right now 0, plus the value. So if I say I love this lovable movie, then we have 2 goods. And then the weight. US. Okay, wait. Yep. I really should stop using Korean words. I feel like I am going to confuse people. I am not Korean. Okay. This is weight. So if it's negative, it becomes minus. Okay. And if it's so the output is just positive or negative because it's a this or that, and then else. So that's a classifier. Calculate accuracy. How do we calculate accuracy? Total number. Oh. Okay. So total number, correct number for xy being these two, right? Do we have xy data? Yes. Raw, red. Okay. For xy in xy data, y is the prediction. We call this, and then total is how many we're doing, right? And then if y this is the same as our prediction, then it's correct. And then that's the accuracy. Hey, I understand stuff. Label count, we just have 2 labels. And then we do test and training accuracy, error analysis, find error. What is that? An important part of improving any system is figuring out where it goes wrong. The following 2 functions. I see one. Allow you to randomly observe some mistaken examples which may help you improve the classifier. Feel free to write more sophisticated methods of error analysis as well. No thanks, I'm good. I don't know why we're doing this or what is the outcome. I want to see what the data looks like, because the thing should already be there. What's the thing? Prediction. So it's in sentiment and class 3. What? Okay, 3. Why 3? Okay, so this is what the data looks like. 1 positive, 0 negative, I think. And then this is a divider, and this is, yep. Okay, now I understand better. I knew if I looked at the code, I'd understand better. Am I going to check the reading material? I don't know. I'm gonna go and look at lecture 2 now. Is reading material supposed to be pre-reading or while reading? We have the code that we can look at for later. Okay. So.
And so now I want to talk about some solutions to the problems in this class.
So, hold up. I looked at the rule-based classifier. Then, second part is the bag of words. Sentiment classifier, which is more ML than it is rule-based. And the point there is, bag of words is not the best sentiment classifier. And okay, so the data reading is the same. The feature extraction is that you just take every word and you give it, is that supposed to be one hot encoding? I think maybe. And then we have 0 weights. Reading data is the same. Running the classifier. Okay, training, that's what I was about to ask. When are we training it? Because rule-based, you don't need to train it, but bag of words, you do. So this is the thing that does the classification, which is, again, same. But the training is what's different. So the word epoch is a fun word, because if you are not in the know, you're like, why? Because I think the word epoch on its own is supposed to mean like century? No, just time of in history, not century. Okay, at the beginning of a period. So it has an actual meaning. Yeah, but in computing it just means fixed date and time used as reference from which a computer measures system of time. Okay. So yeah, the word epoch sounds fantastical, doesn't it? So we are training it for 5 epochs, and we're saying for that, starting with 1, so we have to give it a +1. If we started with 0, then we didn't need to give it +1. Shuffle the order of the data. Okay, we are doing a random shuffle. I don't know why we're doing that. And then run over all data points. Don't run them over, just run this. 4. This list that we have, which is the ID of the data. Did we give them IDs from, or let me see if data already existed. Oh, we're using the same data. Okay. What does TQDM means? I don't know what 2QDM means, but I guess it's supposed to be the ID. Did we talk about TQDM should stand for? Tree bank. No, I don't know. Okay. X is the X ID. Y is a progress bar. Huh. I did not. Oh yeah. I mean, thank you. I could have googled it. Thank you. Do I call you Dazo or do I call you something else? Let me know. All right. So, is it checking for the epoch? تقدم, of course. That makes sense, which means like to go forth, progress. Yeah, basically. That's cool. No way. That's so cute. So what is it from? Didn't know it could be so cute. All right. Okay. Thank you. If you hadn't told me what it meant, I wouldn't have Googled it and I wouldn't have been happy with the different types of meanings. Just wrap any iterable and it shows us progress. That is awesome. I'm not running the code, so I won't be able to see it, but we have X and Y, and if it's 0, we continue. Why? Because there is no data there. Got it. And then for the features, the feature extraction is the same. Okay. And then we run the classifier. Are we doing that for each data so that the weights get updated? I use it all the time. That's pretty cool. I just heard about it. تقدم. So if they are not the same, we update the weights based on y times the feature. Okay. Is the evaluation code also the same? Yes, it is. Huh, pretty cool. I am not checking this for some reason, but the fact that the only difference between the rule-based and the bag of words being the training part, but also I think it should also be this part. Let me double check. Feature extraction. No? Definitely that. Yeah, because this is where the rule part is. But here we're just doing the giving it the one, which is almost like the one, I think it is called the one hot encoding. Okay, now I feel a bit more ready to go to class too, because I was thinking, I was like, if this was a real class, would I just go to lectures being ill-prepared? Hell no. I'm a teacher's pet through and through. But when the class is online, you're like, teacher won't see me. And yeah, so we have issues with the bag of words, even though it's pretty okay, but it's still like, I think last time he ran it with the test and stuff, it was 56%. So we have issues with subword model. Oh, no, sorry, with conjugated or compound words, words that are similar, combination features, especially negation, and then the handling of sentence structure, which is
So the solution to the first problem, or a
with the, yeah, okay, contradiction and stuff. Okay.
solution to the first problem is subword or character-based models, and that's what I'll talk about first. Handling of word similarity, this can be handled using word embeddings. And the word embeddings will be another thing we'll talk about this time. Handling of combination features, we can handle through neural networks, which we'll also talk about this time. And then handling of sentence structure. The kind of standard way of handling this now is through sequence-based models, and that will be starting in a few classes. So let's jump into it.
Okay.
So subword models. As I mentioned, this is a really important.
So we're going to look at all the models that he mentioned for solving issues of bag of words. Okay. Starting with subword models. For some reason, I haven't heard that subword and model as a thing. Like I know you can just say if contains and then you're good. Loved, loving, lovable. I think all of them contain LOVE. Maybe not loving. No. Anyway.
Important part of all of the.
Oh my god. Who let the cat in? Look, Yuki. I will say I love you, but we. Oh god, really? Add. But we don't let
The word
cats
embedding.
inside because because we have a lot of stray cats. And we don't let them inside. I'm really sorry. Oh my god. Hi. Welcome. So cute. Um oh. Yeah. I mean, you can still play in the garden if you want. We do allow that. um were you streaming earlier, or was that yesterday that I didn't catch you? Oh my god, so adorable. Um how is Long Yuk doing? Ah, okay, yesterday. I am currently in my um, academic girly era, and we are in a lecture, I guess. Um, we are looking at this lecture um, from the amazing Graham. I think it's Newbig, but I also feel like saying Newberg for some reason. He's such a. She's going well. I think she just needs a visible body now. Wow. Okay. I mean, yeah, you can always say one little thing left, and then when you get lost, you don't know how to come out of the hole you've digged for yourself. And I'm just talking about myself, not you. Yeah. Mm, I think that guy has a website that I want to go to. I mean, I think I'm already there. No? Oh, is that his website? This thing with the PH? I guess it is. I know, like, he's been at this for a while. Do you have any old papers that are, like, super famous? Because I think, anyway, he's cool. And, yeah. Now we are looking at subword models. Let's see how, because they're not neural networks, I don't know what, oh, okay. I don't know what subword models are supposed to be. Like, are they ML or not? Let's see.
Will be another thing we'll talk about this time. Handling of combination features we can handle through neural networks, which we'll also talk about this time. And then handling of sentence structure. The kind of standard way of handling this now is through sequence-based models, and that will be starting in a few classes. So let's jump into it. So subword models. As I mentioned, this is a really important part of all of the models that we're building nowadays, including state-of-the-art language models and things like this. And the basic idea behind this is that we want to split, in particular, split less common words up into multiple subword tokens. So to give an example of this, if we have something like the companies are expanding, it might split companies into companies and expand ing like this.
Is this like sort of rule-based? How would you know to do that? Because if it's not rule-based, then I guess it would have to be ML.
And there are a few benefits of this. The first benefit is that this allows you to parameters between word varieties or compound words. And the other one is to reduce parameter size and save compute and memory. And both of these are kind of like equally important things that we need to be considering. So, does anyone know how many words there are in English? Any ideas?
That's a fun question. How many words are there in English? What is a word?
Yeah, 2 million. Pretty good. Any other ideas? Yeah.
What do you mean? 6 if you count subwords. Also, I don't know why you keep gave this emoticon. I am trying, well, emote. Oh, it was a joke. Because I was like, why 6? Okay.
Some models use 60,000. I think
Huh.
60,000 is probably these subword models.
Actually,
When
that's
we
really
talk about
close.
this.
60,000. Extremely close.
So they can use subword models to take the 2 million, which I think is a reasonable guess, to 60,000. Any other ideas? 700,000. Okay, pretty good. So this was a great question. It doesn't really have a good answer, but 200 million is probably pretty good. 700,000 is pretty good. The reason why this is a trick question is because our company and companies different words. Maybe not, right? Because if we know the word company, we can, guess what the word companies means. What about automobile? Is that a different word? Well, maybe if we know auto and mobile, we can kind of guess what automobile means, but not really. So maybe that's a different word.
Definitely, you need to answer what does a word mean to you? Because, yeah, okay.
There's all kinds of shades of gray there. And also, we have really frequent words that everybody can probably acknowledge are words like the and maybe car. And then we have words down here which are like misspellings or something like that, misspellings of actual correct words or slang.
Oh, yeah,
And other
that's what
things
I
like
was
that.
about to
And
say.
then it's questionable.
Because slang is always being created, so you can never stop having words. Should be, especially, yes, yes. It should help with making your vocabulary size of the vocabulary not be messed up with other words. Like if company is company and I don't know, that was a bad example. But yeah, it should be pre-processing and but because this model is focusing on subword, then I don't know if we can call that pre-processing. But for other models, should be, right?
Whether those are actual words or not. So
Also, I guess there are different ways of doing it. You can just not do it and have this as a part of your vocabulary. Then company and companies would be different words then.
there's a famous
You can check out ChatGPT's tokenizer. Ah, huh. That's pretty cool. Oh, we can see it? So we don't. Do we know what it's using? Text using tokens which are common. I did hear that there are models that don't even use words as units. They go like smaller. And not, maybe not even characters. You can do character as well. Common sequences of characters found in text. The model learns to understand the relationship between these tokens and excel at producing the next token. So if I give you a sentence as an example, so it's important to note that this part. Dot. Oh, we can see it here. So it. Do we know what they are supposed to stand for? The colors, or are they just colored for no reason? Ah, I can. Yeah, subwords. Okay, okay. So it, and then is, and then what else? Tokenization. Yep, 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 yep. Anything else? Something that has. Okay, I'm gonna take this part because I think. Would it recognize token and then the S? Oh, okay, so it's one thing. Yeah, there's no cutting here. Each color is yeah, it doesn't have to mean something, but it is a token in the vocab. Oh. Helpful rule of thumb is one token is generally corresponds to 4 characters. I mean, not always, but that's pretty okay. Huh. Interesting. I hadn't seen this. Thank you for sharing. Yeah, it has to be an average. Okay.
Law called zips law, which probably a lot of people have heard of. It's also the source of your .zip file, which is using zips law to compress outputs by making the more frequent words have shorter byte strings and less frequent words have less
More
frequent byte strings. But
importance?
basically, like, we're going to have an infinite number of words, or at least strings that are separated by white space. So we need to handle this somehow, and that's what subword units do.
Okay.
So 60,000 was a good guess for the number of subword units you might.
Subword units. I wonder if it would be easier for ChatGPT's model to learn if they broke down words more by common parts, like how you expected token plus S. To change now would yeah. Yeah, good point. That's a good point. Someone with a lot of resources should check that. Probably, yeah. Tokenizer, like even on Hugging Face, there are tokenizer models, feature extractors, methods, stuff. Like each part of them, the thing. Yeah, it is pretty interesting because, like, all of the discussion we're having is with English. What about other languages? And then it becomes even more interesting.
Use in a model, and so by using subword units, we can limit to about that much.
So it does help our vocabulary size not be too big. Yep, yep.
A couple of common ways to create these subword units, and basically all of them rely on the fact that
what? There are other languages? That's funny. So many tokens for all the kanji. Yeah. I actually don't know kanji. Hey! The morning coffee is here. Hi, hi. So, yeah. Yeah, tokenization should be easier for languages with good rules. I don't know if Japanese has like easy to follow rules. Because if you look at it, like squint your eyes and look at it, English has rules. And then when you open your eyes, there are no rules. It's anarchy. Um, but then rule-based isn't the best way to go in this time, like with the knowledge that we have right now.
More common strings to become subword units. Or actually, sorry, I realize maybe before doing that, I could explain an alternative to creating subword units. So the alternative to creating subword units is to treat every character or maybe every byte in a string as a single thing that you encode into there. So in other words, instead of trying to model the companies are expanding, we model T, H, E,
Oh, every
H,
character?
C, O, M, et cetera, et cetera. Can anyone think of any downsides of this? Yeah.
We just lose all meaning. And then we have 26 characters with punctuation and stuff.
Yeah, the set of these will be very small, but that's not necessarily a problem, right?
Context?
Yeah. Any other ideas? Yeah. Yeah, the resulting sequences will be very long. And when you say difficult to use, it can be difficult to use for a couple of reasons. There's mainly two reasons, actually. Any ideas about those? Yeah. Yeah.
Any ideas? Are we talking about um, giving character vectors, like vectors that are based on each character? Is that what we're talking about? Because I thought he was talking about how to split, and if it's character, then it's not. The sizes shouldn't be that big, right?
Yeah, that's a little bit of a separate problem than the character-based model, so let me get back to that. But let's finish the discussion of the character-based models. So
Okay.
if it's really long, maybe a simple thing, like let's say you have a big neural network and it's processing a really long sequence. Any ideas what happens?
Time?
Basically, you run out of memory, or it takes a really
Ah,
long time,
and
right? So
okay.
you have computational problems. Another reason why is think of what a bag of words model would look like if it was a bag of characters model.
Ah.
It wouldn't be very informative about whether like a sentence is positive sentiment or negative sentiment, right? Because instead of having G-O.
It introduced another level of abstraction. Yeah, and like if you just boil down every word into characters and not have it be unique, it's just same letters repeating without any meaning, right? The size of the embedding vectors is independent of what you are embedding. So they are fixed. Uh, well, never mind. It could be dependent if you use one hot encoding. Yeah. Still, uh, embeddings are fixed size, I guess. Okay.
OOD, you would have, instead of having good, you would have GOOD, and that doesn't really directly tell you whether it's positive sentiment
Whoa,
or
whoa,
not.
whoa. Can you
Having
repeat
good,
that?
instead of having GOOD, you would have, instead of having good, you would have GOOD, and that doesn't really directly tell you whether it's positive sentiment or not. So those are basically the two problems. Compute and lack of expressiveness in the underlying representation. So you need to handle both of those. Yes.
Each time I
So
can
very good question.
barely hear them, I remember that my voice is also super low. Yes! Um, uh, the teacher is being like answer me. It's fun.
Question, I'll repeat it. And actually, this also goes back to the other question you asked about words that look the same but are pronounced differently or have different meanings. And so, like, let's say we just remembered this whole sentence, right? The companies are expanding. And that was like a single embedding, and we somehow embedded it. The problem would be we're never going to see that sentence again. Or if we go to longer sentences, we're never going to see the longer sentences again. So it becomes too sparse. So there's kind of a sweet spot between like long enough to be expressive and short enough to occur many times so that you learn appropriately. And that's kind of what subword models are aiming for. And if you get longer subwords, then you'll get things that are more expressive but more sparse. And shorter subwords, you'll get things that are like less expressive but less sparse. So you need to balance between them. And then once we get into sequence modeling, they start being able to model like which words are next to each other, which tokens are next to each other and stuff like that. So even if they are less expressive, the combination between them can be expressive enough. So yeah, that's kind of a preview of what we're going to be doing next. Okay, so let's assume that we want to have some subwords that are longer than characters but shorter than tokens. How do we make these in a consistent way?
Longer than character, shorter than what? Sorry.
Longer than characters but shorter than tokens. How do we make these in a consistent way? There's two major ways of doing this.
I thought I had this on. Okay.
The first one is byte pair encoding, and this is very, very simple. In fact, it's so simple that we can implement it
now?
in this notebook here, which you can click through to on the slides. And it's about 10 lines of code. And so basically what byte pair encoding does is that you start out with all of the vocabulary that you want to process, where each vocabulary item is split into the characters and an end of word symbol. And you have a corresponding frequency of this. You then get statistics about the most common pairs of tokens that occur next to each other.
Pairs of tokens. Okay, so this is how many times this part is repeated, right? Incrementally combine together the most frequent token pairs. Okay, these are not bigrams, right?
And so here, the most common pairs of tokens that occur next to each other are ES, because it occurs 9 times, because it occurs in newest and wildest. Also ST and TW, because those occur there too. And then you have WE and other things like that. So out of all of the most frequent ones, you just merge them together. And that gives you new EST and wide EST. And then you do the same thing. This time now you get EST. So now you get this suffix EST. And that looks pretty reasonable for English, right? You know, EST is a common suffix that we use. It seems like it should be a single token. And so you just do this over and over again. If you want a vocabulary
get stat of pairs merge, get stat of pairs merge. Is that the idea?
60,000, for example, you would do 60,000 minus number of characters merge operations, and eventually you would get a vocabulary of 60,000. And yeah, very, very simple method to do this. Any questions about that? Sure. Yeah. Mm-hmm. 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 Yeah, so just to repeat the comment, this seems like a greedy version of Huffman encoding, which is similar to what you're using in your zip file, a way to shorten things by getting longer, more frequent things
More
being
time.
encoded as a single token. I think
I barely remember the Huffman encoding that we studied in undergrad. But yeah, the idea is that repeating things shouldn't take up space. Things that are unique should take up more space. Okay.
think byte pair encoding did originally start like that's part of the reason why the encoding thing is here. I think it originally started there. I haven't read really deeply into this, but I can talk more about how the next one corresponds to information theory. And
Hmm.
Tuesday, I'm going to talk even more about how language models correspond to information theory. So we can discuss maybe in more detail then too.
Okay.
So the alternative option is to use
Hey.
unigram models. And unigram models are the simplest type of language model. I'm going
Okay. So this byte pair thing doesn't have to do with engrams. Okay, I guess.
to talk more in detail about them next time. But basically, the way it works is you create a model that generates all words in the sequence independently. Sorry, I thought I had a
What are we
I thought I had
splitting
an
on?
equation, but basically the equation looks like
Uh-oh, I just realized you guys can't see the lecture. Oh no.
so you say the probability of the sequence is the product of the probabilities of each of the words in the sequence, and then you try to pick a vocabulary that maximizes the probability of the corpus given a fixed vocabulary size. So you try to say, okay, you get a vocabulary size of 60,000. How do you how do you pick the best 60,000 vocabulary to maximize the probability of the corpus? And that will result in something very similar. It will also try to
No worries, no worries. The just listening part is also something that I do sometimes. Haha, both teachers. um, we should get him some cat ear headphones. But yeah, he was behind me. That's what I meant. Yeah.
and that will result in something very similar. It will also try to give longer vocabulary, sorry, more common vocabulary, longer sequences, because that allows you to maximize this objective. Um, the optimization for this is performed using something called the EM algorithm, where basically you predict the uh, the probability of each token showing up, and then select the most common tokens, and then trim off the ones that are less common, and then just do this over and over again until you drop down to the 60,000 vocabulary range. So the details for this are not important for most people in this class
Huh.
because you're going to just be using a toolkit that implements this for you.
Right.
But if you're interested in this, I'm happy to talk to you about it. Yeah. Oh, in unigram models, there's a huge problem with assuming independence in language models because then you could rearrange the order of words in sentences. That's something we're going to talk about in
Oh
language
god,
modeling.
that scared me. What was that? That was something? No? Something happened? Did anything happen? Something did happen, no? I didn't. What was that? Okay. It wasn't YouTube, right? Because YouTube doesn't have alerts. I don't know. Because my activity feed is empty. I mean, not empty, like, there's nothing new. Alright, no problem.
But the good thing about this is the EM algorithm requires dynamic programming in this case, and you can't easily do dynamic programming if you don't make that assumption. And then finally, after you've picked your vocabulary and you've assigned a probability to each word in the vocabulary, you then find a segmentation of the input that maximizes the unigram probability. So this is basically the idea of what's going on here. I'm not going to go into a lot of detail about this because most people are just going to be users of this algorithm, so it's not super, super important.
Mm-hmm.
The one important thing about this is that there's a library called sentence piece that's used very widely in order to build these subword units. And basically, what you do is you run the sentence piece train program, and that gives you you select your vocab size. This character coverage is basically how well do you need to cover all of the characters in your vocabulary or in
Vocab size is something you give it? Would you know? Like, you can limit it?
your input text. What model type do you use? And then you run this sentence piece encode file to encode the output and split the output. And there's also Python bindings available for this. And the one thing that you should know is by default, it uses the unigram model, but it also supports BPE. In my experience, it doesn't make a huge difference about which one you use. The bigger thing is how big is your vocabulary size? And if your vocabulary size is smaller, then things will be more efficient, but less expressive. If your vocabulary size is bigger, things will be more expressive, but less efficient. And a good rule of thumb is like something like 60,000 to 80,000 is pretty reasonable if you're only doing English. If you're spreading out to things that do other languages, which I'll talk about in a second, then you need a much bigger vocabulary size.
Okay.
So there's two important considerations when using these models. The first is multilinguality, as I said. So when you're using
but I think like a vocab size can be used to stop tokenization algorithms like we are looking at. I think we can like give them some sort of limit. I have been trying to find this source of alert. It could be that I think Restream or no way. I don't know. Alerting me with YouTuber subscribers could be that. Because I did get an alert, but I don't know what it was, and now I'm guessing could be YouTube subscribers. Cool. The cool people watching from YouTube, thank you. You are sometimes neglected, but I can see your chat if you give me chat. And the you are sometimes neglected is not my fault, because I don't neglect you. It's just that YouTube is not as, yeah, I think they say that the live streaming culture, the streaming culture is not as alive on YouTube. But honestly, I watch live on YouTube, so it's fine. I'm just saying I'm one of you.
subword models, they're hard to use multilingually because, as I said before, they give longer strings to more frequent strings, basically. So then imagine what happens if 50% of your corpus is English, another 30% of your corpus is other languages written in Latin script, 10% is Chinese, 5% is Cyrillic script languages, 4% to 3% is Japanese, and then you have like 0.01% written in like Burmese or something like that. Suddenly,
Okay.
Burmese just gets chunked up really, really tiny, really
Huh.
long sequences, and it doesn't work as well. So
I
what
mean, I bet multilingual just models is really not easy, and it's pretty cool how multimodal, multilingual language models, the fact that they exist is pretty cool. Like it's like they shouldn't exist, but they do. Or maybe it's just some good trickery in the back end that we don't see. Like there are identification language ID stuff models, and then they reroute you to language models that are for that language only. Could be that. Don't know.
one way that people fix this, and actually there's a really nice blog post about this called Exploring BERT's Vocabulary, which I referenced here if you're interested in learning more about that. But one way that people work around this is if your actual data distribution looks like this, like English, Chinese, actually, sorry, I forgot the Indian languages in my example. Apologies for that. Hindi, all the other ones. So like, let's say we have what you do is you essentially create a different distribution that like downweights English a little bit and upweights all of the other languages.
Because
So that you get more of the other languages when creating languages. So this is a common work.
it neglects repeated stuff and gives more priority to not repeated stuff, which means languages with less frequency get more importance, priority. I think it might be with humans where multilingual humans are smarter. I mean, if this is true or not, I will give my support to it. Because, yeah. And what does it mean to be multilingual? Is it 2 languages or is it more? I'm gonna give it 2 languages. If you know 2 languages, you're multilingual. Who came up with the word bilingual, you know?
The second problem with
Can confirm. Oh, don't say that. Hi. Um, welcome. So cute. Um, I doubt you speak 1 languages. As far as I'm aware, isn't there some sort of dragon language? Like someone who knows more about Lord of the Rings, let me know. Maybe you can speak Benedict Cumberbatch, the way he speaks. um, isn't there a dragon language? There really should be. Because I was watching Elemental recently, and there's a fire language. So languages, there are a lot of them.
these is arbitrariness. So as you saw in my example with BPE, ES, ST, and T end of word symbol all have the same probability or have the same frequency, right? So if we get to that point, do we segment ES?
Who_gifted a tier 1 subscription to YukiVidi.
So, hi. Thank you. Two, could you please? Oh, thank you. And could you please not do that next time? Or like, There should be some sort of limit, really. I'm gonna check some settings. um, it, Thank you, honestly. But I don't know, like, I understand dragons should have a lot of gold, but I also understand that they don't want to give it away, right? No? Is my understanding wrong? Um, Thank you. Uh, okay, I guess generous dragons exist. Um, Thank you, but also you don't have to. Um, my voice is becoming lower. Okay. Um, mhm. The vibes are vibing, but yeah. Oh, I just remembered. You really should go to sleep. Um, do that, okay? Sometimes people are sleepy and they make decisions that should be, slept on. Again, I'm not trying to sound rude. I hope I'm not sounding rude. Good night.
Or do we EST, or do we segment EST? And so this is also a problem, and it actually can affect your results.
Yeah, there's an interesting thing people did recently where they poked around in an LMM and found individual neurons that reacted to very specific things. Whoa. Wonder if you saw it. Nope, did not see it. LLM, yeah, I know. Sorry, I even, yeah. Yeah, please, if you can find it, do that. Um, so I don't want to. Oh, thank you so much. I don't want to. Like, if you didn't have it. Oh, that's very recent. The mind of a large language model. That is really cool. More examples. If you click read the paper. Ah, so it is a paper. Where is this here? Ah, whoa. I'm looking at the scroll button, and that's super small, which means this is very long and informative. Um, Question: have you read the blog? Or the paper? Because that is very interesting, and the fact that it's multilingual even. Look at that. Thank you. My sleep decisions are bad. My daytime ones don't get any better. That's funny. Um, but we'll get to sleep. Thank you for a comfy stream. Thank you for stopping by. Honestly, thank you. Sleep well. Skipped where they had these highlighted text parts. Golden Gate. Golden Gate. Q 또는 금문구. This is the same text. Something about Golden Gate. Thank you. Billy Bob? Who's Billy Bob? Manually override the values of those neurons to very high or very negative values and see how that influences text generation. That is really interesting. Okay, so I was about to say, we have this idea. Again, I don't want to bring it up because I understand it's a commitment and from now, like, I'm not expecting anyone to be a part of the idea. Um, best streamer if I recall. Oh, huh. That I was not aware of. Yeah, so we are having this idea of sharing things, and then doing some sort of like show and tell regarding the things that we find on the internet. And like this is an example of um, like reading it and then explaining it to other people style. I could do that for this one. I'm not gonna ask you to do that. um, but I will say what it is in case you're interested. The idea is that we'll have a Discord channel, right? The things are called channels, right? Yep, channels. Um, oh God. Oh hi. Uh, what is do in on Discord? They really need to go to sleep. Um, that is funny. Okay, Billy Bob is a good name. Like easy to remember. Mm, yeah. So I I will try to text to speech my way into reading this and see how far I can go because I almost always have a hard time reading long text. Um, yeah. Still, we report a significant advance in understanding the inner workings of AI models. We have identified how millions of concepts are represented inside Claude Sonnet. Is that an LLM? Ah, this is the first ever detailed look inside a modern production grade large language model. This interpretability discovery could in future help make AI models safer and also no way. I love getting distracted with good information. Um, wait, what was I about to say? Yeah, this is like interpretability because right now, literally what I was about to say, AI is black boxed. Um, we do that, don't we? Okay. All right. I'm gonna put this as a homework for myself and also link put a link. I don't like them having to justify the cool findings at the top. Just find actual findings. Um, mm, all examples that they give later on are truly fascinating. I am going to put that in the Discord channel for interesting links. Should also say that it's not my find, but yeah. um, okay. Mm-mm-mm. Okay. um, thanks. That was um, that was really cool. All right. I am going to now. Um, up there. Okay. Uh, yes. The thing is, yes. Oh my God. Go to sleep. How is it nearly 6 a.m.? Sorry. My brain is trying to put you in a time zone. Do go to sleep. Please do that. Um, because it's good to sleep before 10 p.m. um, hmm? How what? Sorry. Huh? Oh, the thing is, I don't want to ask people to join Discord. Like, I want it to be something that they seek out and not me telling them to go to it, because it's, yeah. Oh, how it's 6 a.m. I know. Sometimes I have a hard time believing time is not a construct, human-made thing, and that it's real, and that it happens. Yep. All right. You should go to sleep, and I should go back to this part. Thank you. Sleep well, have nice dreams, and please try to sleep earlier. As a big sister, I want people to have healthy sleep schedules. Okay. Um, yeah, okay. Ah, huh. Okay, so I'm going to watch this video for 6 more minutes and then see if I can jump to Hugging Face. We're just going to finish this. Sleep is hard. Okay, the trick is waking up early. You wake up early, I am the type of person who it takes 1 hour to go to sleep. And if I wake up super early, then it takes me half an hour. So yeah, listen to your favorite podcast and go to sleep. Sleep well. You can fall asleep to the sound of ML. Then you have nightmares. I don't recommend that. I recommend don't judge me. I recommend listening to true crime podcasts. Then you won't have nightmares, because then the nightmare is in real life. Fun, right?
Especially if you like don't have a really strong vocabulary for the language you're working in, or you're working in a new domain. And so there's a few workarounds for this. One workaround for this is called subword regularization. And the way it works is, instead of just having a single segmentation and getting the kind of maximally probable segmentation, or the greedy one that you get out of BPE, instead you sample different segmentations at training time and use the different segmentations, and that makes your model more robust to this kind of variation. And that's also actually the reason why sentence piece was.
So you just make different segmentations for the same thing? Is that regularization?
Released was through this subword regularization paper. So that's also implemented in sentence piece, if that's something you're interested in trying. Cool. Are there any questions or discussions about this? Yeah. Yeah.
Why does this muffled sound feel so, I don't know, there's something really calming listening to distant sounds, like this background style.
Yeah, so this is a good question. Just to repeat the question, it was like, let's say we have a big multilingual subword model, and we want to add a new language in some way. How can we reuse the existing model but add a new language? It's a good question. If you're only using it for subword segmentation, one nice thing about the unigram model here is this is kind of a probabilistic model. So it's very easy to do the kind of standard things that we do with probabilistic models, which is like, let's say we had an old vocabulary for this. We could just interpolate.
Interpolate what? Can we see what he's writing?
We could interpolate like this and just, combine the probabilities of the two and then use that combined probability in order to segment the new language. Things like this have been done before, but I don't remember the exact references for them. So, but that's what I would do here. Another interesting thing is, this might be getting a little ahead of myself, but there's a
I'm not muting him. He's just quiet.
there's a paper that talks about how you can take things that were trained with another vocabulary. And basically the idea is you pre-train on whatever languages you have, and then you learn embeddings in the new language. You freeze the body of the model and learn embeddings in the new language. So that's another method that's used. It's called on the cross-lingual transferability of monolingual representation. And I'll probably talk about that in the last class of this thing, so you can remember that. Cool. Any other questions? Yeah. Is bag of words a first step to process your data if you want to do generation?
No?
You mean like
Pre-processing?
a word-based model or a subword-based model, or? Mm-hmm. So the subword segmentation is the first step of creating just about any model nowadays. Like every model uses this, and they usually use this either to segment characters or bytes. Characters are like Unicode code points, so they actually correspond to an actual visual character, and then bytes are, many Unicode characters are like 3 bytes. It's like a Chinese character is 3 bytes, if I remember correctly. So
I don't know that.
the byte-based segmentation is nice because you don't even need to worry about Unicode. You can just do you can just segment the file like literally as is, and so a lot of people do it that way too. Llama, as far as I know, is bytes. I believe GPT.
No way. Yeah, UTF-8. I've needed that quite a lot working with non-English text. Like just being a baby, knowing if you want to write in your language, you have to have Unicode. Like you learn your ABCs and you learn that working with right to left, left to right is different. But Llama uses byte. You heard that right?
Llama, as far as I know, is bytes. I believe GPT is also bytes, but previous to like 3 or 4 years ago, people used characters also. Yeah. Cool. Okay, so this is really, really important. It's not like super complex, and practically you will just maybe train or maybe just use a tokenizer, but that's an important thing. Cool. Next, I'd like to move on to continuous work.
No. I love word embeddings, I really do, but I have to be fair and go to the second part, which is this thing. Okay, let's be careful with the sound because I know. Let's see how loud this video is. Instantiate a transformers model using PyTorch. Let's see. Yep, the whoosh is whooshing and is being loud again. Wait, I don't think that works for you guys. I think that's just for my ears. Oh god.
How to instantiate a transformers model. In this video, we'll look at how we can create and use a model from the Transformers library.
Okay.
As we've seen before, the AutoModel class allows...
Okay, the sound shouldn't be super loud. I think a thing has been to reserve bytes for stuff not seen during tokenization and just pass them to the model during training. That is quite interesting. To handle language sequences not seen during tokenization. I don't think I had any info on this, which is like, it makes a lot of sense because that's how a computer sees stuff. Gemini and Gemma did that, and apparently Llama and ChatGPT, so it is something that is being done. Very cool.
allows you to instantiate a pre-trained model from any checkpoint on the HuggingFace hub. It will pick the right model class from the library to instantiate the proper architecture and load the weights of the pre-trained model inside.
So what we were talking about last time was that I don't think ChatGPT did that per se. The teacher just said that, so I mean, did he, or did you just didn't he just say that? Maybe he said something along those lines. Yeah. Okay. So to bring my brain back here, what we're mostly doing and did last time was say, look how easy it is using Hugging Face to work with models, but also when you call something, this is what happens in the back end, sort of. Not like detailed enough that you can make changes. That was the pipeline thing. And now
To instantiate the proper architecture and load the weights of the pre-trained model inside. As we can see,
the weights.
when given a BERT checkpoint, we end up with a BERT model, and similarly for GPT-2 or BART. Behind the scenes, similarly for GPT-2 or BART.
Okay, but we're calling them. No, we're not calling them? We are calling them. Okay.
Behind the scenes, this API can take the name of a checkpoint on the hub, in which case it will download and cache the configuration file as well as the model weights file. We can also specify the path to a local folder that contains a valid configuration file and a model weights file. To instantiate the pre-trained model, the AutoModel API will first open the configuration file to look at the configuration class that should be used. The configuration class depends on the type of the model, BERT, GPT-2, or BART, for instance. Once it has the proper configuration class, it can instantiate that configuration, which is a blueprint to know how to create the model. It also uses this configuration class to find the proper model class, which is then combined with the loaded configuration to load the model.
Okay.
This model is not yet a pre-trained model, as it has just been initialized with random weights. The last step is to load the weights from the model file inside this model. To easily load the configuration of a model from any checkpoint or a folder containing the configuration file, we can use the AutoConfig class. Like the AutoModel class, it will pick the right configuration class from the library. We can also use a specific class corresponding to a checkpoint, but we'll need to change the code each time we want to try a different model architecture. As we said before, the configuration of a model is a blueprint that contains all the information necessary to create the model architecture.
This is the thing that you do the setting if you want, or you can get it based on what is currently being used for the model you're naming. Okay.
For instance, the BERT model associated with the BERT-based case checkpoint.
I don't know whether it was said in the tokenization stuff, but I think there's a hope that what it will learn with subword tokenization will roughly align with lemmatization and stemming. Are these more rule-based, right? Yeah, I have heard of them, and stemming is supposed to be like going back to the origin of the word, right? Yes, yes. Uh, mm, 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 mm. Okay, yeah. Um, got it. They are rather rule-based, especially for things that can follow rules. Pretty cool. Hmm. I think the most textbooks talk about them because they are traditional NLP. No. Huh.
Has 12 layers,
What?
a hidden side of 768, and a vocabulary size of 28.
Probably, definitely. Um, like you would hope that it would happen. Uh, mm, mm, mm. Yeah, in a way, it is an assumption because if you don't know what the model sees, then you can't know, but you hope, because like sometimes you anthropomorphize stuff. Um, yeah, yeah. See, it is like you think that it understands the language the same way you do. Um, mhm. Even if you don't say it, maybe you do think it.
1996.
Mhm.
Once we have the configuration, we can create a model that has the same architecture as our checkpoint, but is randomly initialized. We can then train it from scratch like any PyTorch model. We can also change any part of the configuration by using keyword arguments. The second snippet of code instantiates a randomly initialized BERT model with 10 layers instead of 12.
Okay.
Saving a model once it's trained or fine-tuned is very easy. We just have to use the save pretrain method. Here, the model will be saved in a folder named myBERT_model inside the current working directory. Such a model can then be reloaded using the fromPretrain method. To learn how to easily upload this model to the hub, check out the Push to Hub video.
Thank you. If I knew how I understood language, I would need AI to tell me how to teach a computer to do it. Makes me feel like a bad programmer that I can't. I think I would like to think that you are confusing two different parts of being programmer, which one is understanding the problem, one is solving for the problem. Most of the time, especially if working with a client, understanding the problem should not be on you. They should help explain it, and then you give them the solution. And just understanding language, I don't think is such a simple task. We wouldn't have thousands of years of research on it if it was something that could be easily done. I think what our value as CS people is in the seeing how we can apply programming to it, right? So don't feel bad. Yeah. Okay. In this section, we'll take a closer look at creating and using a model. We'll use the auto model class, which is handy when you want to instantiate any model from a checkpoint. Auto model is supposed to give you config and what else? The auto model class and all its relatives, that's funny, are actually simple wrappers over the wide variety of models available in the library. It's a clever wrapper that can automatically guess the appropriate model architecture for your checkpoint and then instantiates a model with its architecture. However, if you know the type of model you want to see, you can use the class that defines its architecture directly. Okay, yeah. Otherwise, the auto model checks it for you, right? So an example with BERT would be you get BERT's config, which is like funny that such a thing as BERT config exists as a method. But since they have to have it, and then you give them config to the model. BERT config, BERT model. Or you can just say auto config and auto model. While you haven't seen all of these attributes, what these attributes do yet, you should recognize some of them. Hidden size attribute defines the size of hidden state vectors, and num hidden layer defines the number of layers. Transformer model have? Is that have? Has. Wait, what? Has, yep, okay. Different loading methods. Creating a model from the default configuration. This is... Sorry. Okay, so this is random. Isn't that the same code that we saw above? Okay. The model can be used in this state, but it will output gibberish. It needs to be trained first. We could train the model from scratch on tasks at hand. We didn't see training from scratch, we just saw using in chapter 1. This would require a long time and lots of data. I guess we saw that it could be done, but we didn't do it. It would have non-negligible environmental impact. Yes, not good for the environment. To avoid unnecessary and duplicate. This is what we studied, that like you don't have to do this if you don't want to. It's imperative to be able to share and reuse models that have already been trained. Loading a transformer model that is already machine learning. Yes, it is machine learning. Hi. Said, what's your question? NLP is machine learning, if that's your question. Also, hello. Is it Sayed or Said? Sorry. Sounds like Sayed. Which, if it's Sayed, then What? What is the last part? It's not Sharikh? No way. Sayyid, maybe, which means in a way it means Mr. That's why I'm trying to say, is it Mr. this person, or I guess a person can be named Sayyid. Okay. See, I get distracted. Loading and transfer models that is already trained is super simple. You just say load from pre-trained. As we saw earlier, we could replace BERT model with equivalent auto model class, which checks it for you. We'll do this from now on, as this produces checkpoint agnostic code. I forgot what the word agnostic means. Help. What? Believes. Oh God, help. That makes no sense. Not like decided. Okay. Because I've heard the word even like, yeah, okay, makes sense. Wait, what? Dedicated? What? Sorry, what's wrong? Okay, so like, we don't want to do it statically, we want to do it dynamically, basically. Okay, it will choose for us. It means that's really funny. Salah, right? That is really funny. Oh no, then that's haram and I shouldn't use it. Yep, got it. Works with any checkpoints. Alright. We shall shut down this stream and never use auto model. Good joke. Oh wow, woohoo. Do you see that or do I see that? No, only I see that. Congratulations, you've received 100 messages today. Pretty cool. Oh yeah, you did see that. Okay, I thought I only saw that. Then yeah, it just becomes dynamic. You don't have to call it out yourself, it will do that. We see it on my, yep, it's on in the overlay but not chat. Got it. If your code works for one checkpoint, it should work seamlessly with another. This applies even if the architecture is different, as long as checkpoint was trained for similar task. Sentiment analysis is an example. Alright. In the code example above, we didn't use BERT config and instead loaded a pre-trained model via BERT. Wait. Oh, we didn't get the config. We just said get what's on the hub. This is a model checkpoint that was trained by the people that made it. You can find more details in the language card. Got it, got it. This model is now initialized with all its weights of the checkpoint, can be used directly for inference on the task it was trained on, and it can also be fine-tuned on a new task. I like knowing how fine-tuning can be. I mean, I guess I sort of know how fine-tuning is done in principle, but I don't think I've succeeded. Oh, I just realized I forgot to plug in the laptop. Cool. Okay. So, by training with pre-trained weights rather than from scratch, we can quickly achieve good results. The weights have been downloaded and cached. We call from pre-trained so that we don't download them in the cache folder, which defaults to here. You can customize your cache folder by setting the... cool. That is useful stuff. Is fine-tuning environment friendly? That's a good question, and it was mostly answered in another chapter here about maybe it was the limitations part. The answer is fine-tuning is better. No, it wasn't here, but it was answered in somewhere around here. Maybe it was how they work or it was what they do. The answer is like hierarchical, where using the model as it is the most environment friendly, and fine-tuning is more environmentally friendly than training from scratch. So it depends on where you're at and how much. I think I do want to go back just to show you the graphs that we looked at and that were very, very interesting. Something about environment? Anyone? I don't remember what it was. I don't think it was in summary. No. Don't think it was in introduction. They don't scare us from introduction, but they did scare us somewhere. Maybe it was here. I swear we saw it. Was it this? It was here. Yep, there it is. It is in the. I can just put this. Wait, let me see. What's the header? Big models. There. You can take a look here, and also, this video is about the carbon footprint of transformers. So I think that answers your question even more. And thank you for asking, because it's something that should not be ignored about models, right? I am currently here. Here? Here. Just checking. Okay, let's see. I do have 10 more minutes, by the way. Yeah, thank you. Are you more interested in the environmental side of ML, or is it something that you are looking into? Like, are you starting, or is it something that you are already interested in? The identifier used to load the model can be the identifier of any model. As long as it's compatible with the BERT architecture. Ah, okay. Saving a model is as easy as loading one. I was about to ask, are we saving it on our computer, or are we pushing to hub, which is something that exists? We use save pre-trained method, which is, how do you read that? Analogous, there we go, to the from pre-trained method. Directory, no way, you just give it a path? Huh. That's surprisingly easy. If you take a look at the config.json file, you can recognize the attributes necessary to build the model architecture. This can also contain some data, such as where the checkpoint originated and what Hugging Face Transformers library version you were using when you last saved the checkpoint. Very interesting. The PyTorch model bin file is known as the state directory. Dictionary. Okay, I've been streaming for too long. It contains all your model's weights. The two files go hand in hand. They hold hands and they go. So we have the config and the model itself, and they have to be together, otherwise they get lost. Configuration is necessary to know your model's architecture, while the model weights are your model's parameters. Oh, cool. Using a transformer model for inference. So directly using it as API style? Right? Right. Now that you know how to load and save a model, thank you. Honestly, good stuff. Let's try using it to make some predictions. Transformer models can only process numbers that tokenizer generates. Yes, I remember we have to do pre-processing. But before we discuss tokenizers, let's explore what inputs models accept. That is a question that I've had for so long. Like, we are talking about transformers, and I know it takes tokens, but like, I guess they did answer it in the last chapter, but it's a question that I've had, like, how do I prepare my thing? Yeah. So, a couple of sequences. Oh wait, I didn't read this part. Tokenizers can take care of casting the input into appropriate framework sensors, but to help me understand what's going on, we'll take a quick look at what must be done before sending inputs to the model. Please do that. So you have a couple of sequences, and all good sequences. I accept them. So the tokenizers convert these to vocabulary indexes, which are typically called input IDs. Yep. Each sequence is now a list of numbers. Okay, we don't know what tokenizer we used, but we did it. This is a list of encoded sequences. List of lists? Tensors only accept rectangular shapes. Think matrices. I am thinking matrices. It does look like a matrix. This array is already... I mean, squares are rectangles, so yeah. But not other way around. So converting it to a tensor is easy. So this is not a tensor. Okay. It's an array. Multidimensional. So you just say torch.tensor, and we technically don't know how this became this, but we used the tokenizer. Oh no. Okay. Using tensor as input to the model, and then you just give it. Making use of tensors with the model is extremely simple. You call the model. So you have text. Okay. This is supposed to be some sort of classifier as an example. Okay. While the model accepts lots of different arguments, only input IDs are necessary. We'll explain what other arguments do and when they are required later, but first we need to take a closer look at the tokenizers that build the inputs that a transformer model can understand. Phew! Okay, that is extremely, we don't need to convert the output. Yes, we do. We do. So again, if you go back to this, we looked at was it in the behind the pipeline? We already looked at it. If you run this code, which says pipeline sentiment analysis, like you can just run this code and it will give you an output, but a tensor is a generalization of a matrix to higher and lower dimensions other than 2. So for a language like Python, it means like that, say, operations like multiplication are defined for a tensor, where what would it mean to multiply 2 arrays together? Okay. I think, yeah, basically, tensor matrix, these should be used interchangeably, because I remember Jeremy Howard doing so. But like, yeah, like even saying a dimensional array, I guess in a way they are. And you like, yeah, I guess it's for Python. Ah, interesting. Okay, cool. To answer Sahil, why did I call you Salah when your name is Sahil? I am really sorry. I like pronouncing names good, so sorry for mistaking, and sorry because you didn't mention it. So tokenizer part is what we just looked at quickly, and then the model, and then post-processing. So if you look at this like high level without going too far into detail with the code, you give it text, the tokenizer makes it into input IDs, You give it to the model. What is the output of the model is called logits. That is not humanly understandable. So you have to do some post-processing to make it human understandable. Cool? So this part actually explains like the code and how it's done, doesn't it? I think it does, yeah. Yeah, see, this part gives you the logit, and then this is what it looks like. It makes no sense. And then when you say, this is a softmax layer for the post-processing. I mean, if you use pipeline, everything is done for you. It's just simple line of code for you just to use what's on Hugging Face. I keep saying GitHub. But if you want to choose things for yourself, like what tokenizer I'm using, what I guess post-processing here is just the softmax layer. Yeah. Even I think in this part, no, I guess it actually does go into pretty good detail for people who are very beginners for Hugging Face. Like it's both like beginner friendly and detailed enough that should help you work on your stuff in a way. Yeah. And then we have fine-tuning a pre-trained model to look forward to, which is pretty cool. All right, we finished this, so we should go to the tokenizers, but I'm not going to do that because my time's up. We did it. We did it. Yay! 2 hours of streaming. Who would have thunk it? Not me. Thanks for the YouTube and Twitch people for what's the word? Wait, no, what's the word? Ah, I want to say tahammul, but I forgot the word in English. What? When you say I can't bear something, what's the opposite of that? What? Yep, I'm gonna Google it. Patience. No. Did someone write it in the chat? Learning? No, I'm trying to use something which is enduring me. Suffering. What? Why? Why can't I find the word I'm looking for? Yeah, bearing, I guess. Pop, pop, pop. Yeah, tolerating. Yep, tolerate works. Definitely thank you for learning with me, but also thank you for tolerating me. I think that is that, because sometimes humans are annoying, which is I am me, a human. So thank you for being here and for answering my questions and for asking questions when you have them, because sometimes when things are not clear and someone else knows answers, that's cool. Oh god, sorry. Yeah. I want to do some sort of Dora recap. Today we learned about, I went over the code of on GitHub from our lecturer professor. I did a quick look at the rule-based classifier and then the bag of words classifier, and then in the lecture going to answer that later. We talked about subword models, and then unigrams were a way of doing that. But even when you talk about unigrams, you have to say what you're splitting on. Like, does the model learn what it should split on? Maybe. Okay. And then Hugging Face, we just looked at the model. How we load and save a model on Hugging Face. Fun. I like to think that I'm progressing the learning well, and I have directed my learning to more detail. Like, it's no more general ML, it's NLP ML, which is a bit more directed. I should probably direct it even more, specialize it more. But let's see where that goes, right? Okay. So thank you for joining me with the learning part, and I guess I sort of stream every day, same time, for almost an hour and a half to 2 hours. And if you're interested, you could join me on Discord, which is in the YouTube description right now. You don't have to. Don't expect too much. Why are you here? I don't know. Is that a question about why are we alive? J. Okay, we have a follow. Oh, but you're not stupid, Captain Stupid. Thank you for the follow. You didn't have to. I mean, I guess, yeah. Thank you. I have been getting close to. I'm not real. It's just a character, but it is made to look nice. I guess. Yep, the algorithm takes us where we most needed but not wanted. Thank you for the follow, Captain Stupid. I have a hard time calling you Captain Stupid, so I'm just going to call you Captain. Thank you, Captain. And now my brain is like old Jack Sparrow. Okay, so if anyone's interested in the face tracking app I'm using, because it looks nice, it's an app that you can get on, has nothing to do with me. I hope they sponsor me sometime. I keep like looking over my shoulder and think, are they mad that I'm using this? But it's their app, so they should be happy about it. The name is in the description. It's called ZEPETO. Okay, everyone drops the end of your name. Pretty cool. Thank you for the follow. Now I have like 95 followers. Ah, how cool is that? It's like funny to think 95 people clicked follow. That's a lot of people. And also you have a really cool icon. Okay, so we are ending the stream. Okay. So you don't stream. Okay. I just tried to stalk you, Mr. Captain. Didn't go too far. So yeah, we are ending the stream. Thank you for joining me, people from YouTube and people from Twitch. Really appreciate it. Numbers are going numbers up. Why? Who knows? Hope you can catch us next time. The time might not be the best, but you can look at the VODs, YouTube, Twitch, if interested. If not, live your life. Your time is yours. I should not steal it. Okay, thanks again. Appreciate your time and attention and energy. I really do get energy from the chat. It's really funny. Like how the chat is its own thing. It's a person. It really is. Catch you next time, hopefully. Inshallah, if nothing goes wrong, I'll be here tomorrow. Gonna end in 5, 4, 3, 2, 1. Bye-bye. Oh my god. Hi. And bye. JavaScript 7.